Okay guys, today we're going to look at using literal formulas, literal equations and formulas. We're still solving. We're still trying to get a variable by itself. We just need to do it in a way where we have more than one type of variable. So look at these examples up here. Can we simplify any of these? G plus K, for example. I cannot simplify G plus K. By the way, my paper is green. I don't know why that was in the printer. Y'all probably can't see it, but it's green paper. Anyway, G plus K is simply G plus K. You can't add or subtract them or do anything else, but you can write G plus K. That's actually how you add them. You have to add them by saying G plus K, because you can't actually really add them the way that they are. Now, what about C minus W? Again, not like terms, so C minus W is about as good as it's going to get. You don't just leave it blank, you write C minus W. What about 2 divided by X? 2 divided by X is just 2 divided by X. That's all it is. You can't do anything with that. It just stays 2 divided by X. Now, number 4, we have the statement here. But notice, these two are like terms, and so are these two. So 3x minus 11x is negative 8x, and negative 8 plus 4 is negative 4. Now, I cannot do anything further with those two, so that's as good as it's going to get. Just like the rest of those. This is the answer to 2 divided by x. This is the answer to C minus W and G plus K. That's important because it's going to set the basis of what I'm going to talk about, is how to add or subtract and solve for equations that have variables in them. So we got this list here. How are we going to do this? Well, remember that solve means get the particular variable by itself. In this particular case, I'm going to tell you which variable to get by itself. Treat variables just like numbers, meaning you can add, subtract, or multiply or divide them. That means if I need to divide away a P or multiply a Q, I can. If I need to subtract, I can as well. Remember your addition and subtraction rules. Remember, only like terms can be added or subtracted. And you can't prejudge what the answer is going to look like. Now, let me jump straight into this. This is one of those things you just got to do. I'm going to solve this equation. Distance equals mass over volume, I believe. Density equals, mass over volume. And I'm going to solve it for M. Okay? Now, that's what this means. When you see a comma and a variable, that's what it's telling you to solve for. Now, before I solve that, I want to refer you back to a problem like this. What if I was going to solve this for x? What would I do? I would multiply this by 5 to both sides. That will cancel out, and I'll have x equals 30. Right? Now, I'm going to take that same idea over here. If I want to solve for m, I need to get rid of this v, just like I got rid of that 5. So I'm going to multiply by v to both sides. Notice that that cancels out, and I'm left with m equals vd. That's a joke, but really it's not. But anyway, vd equals m. So I treated my v just like a 5. It's a number, so it represents a number. Let's look at number 6. I don't know why this started at number. Oh, yes I do. A equals p plus I. Now, all these equations may not be real equations. I don't know if this one is. And I need to solve this for I. Again, that's what that means, solve for I. Now, before I do that, I want to take a look at this example over here, though. I'm going to solve this for x by subtracting 9 from both sides. And that leaves me negative 6 equals x. Okay? Now, the same thing goes here. I'm going to solve for I. I need to get rid of this p. All right? So how do I get rid of that p? Since it's being added, I'm going to subtract it. So this is a minus p equals I. Now, I can't actually add or subtract a and p. I have to just keep it a minus p. That's all I can do. So I don't need to get caught up in what the answer looks like. All right? So that's what we're going to be doing. We're still using the solving rules. We're just doing a little bit more with combining like terms. Let's look at number 7 and number 8. Solve for the indicated variable, and the indicated variable is b. That means I want to get this b by itself. Now, if you remember anything from Algebra 1, that's the main equation from Algebra 1, but we're not worried about that. We're just trying to solve it for b. So I need to get rid of this mx right here. Since they're being multiplied, I can't subtract away the m or just the x only. I have to take them both together. And since I need to move both of them, how about I subtract the whole thing? So this is y minus mx equals b. Is the b by itself? Yes, it is. It's solved. Now, could I have said negative mx plus y equals b? Yes, either one of those is fine. It's okay for either one of those to be. They're both the same thing. What about number 8? I need to solve this for y. That means this 3x has to go and that 4 has to go. Alright, this is just like trying to put an equation in y equals mx plus b form. First thing I need to do is subtract away my 3x. And I'll have 4y equals 12 minus 3x. I can leave it like that if I want. Now I have to divide everything by 4. So y equals 3 minus, not double minus. So it should be, that's 1 minus right there. Now, notice I didn't change that to a decimal or anything. I kept it just like that. Alright? Now, notice my answer is not y equals 7 or 14 or negative 8. You get strange looking answers whenever you have more than one variable. That's okay. So the idea, the overall idea is we're still solving, but we need to move the equations around. But we need to remember, like what I had at the beginning here, that sometimes you're going to have stuff like this, and that's about as good as it's going to get whenever you have variables of different types. So this is solving using formulas and literal equations.